Okay. So go ahead and go back to the laptop. Let's give me trouble. Really? Just going to be that difference. All right. In later chapters, we're going to talk about this thing called normal distribution. A key characteristic of it is it has a bell shape. So notice it starts off low, goes up high in the middle, and then back down symmetrically. So that's kind of how it works. The distribution is approximate, and the maximum is roughly in the middle. So this is kind of something we consider to be a normal distribution. Right there. This one over to it is approximately uniform. Uniform is about the same, so that'd be what a uniform would look like. This is what we call right skewed because it's sort of like getting yanked off a little bit off to the right. It's left skewed because it's sort of getting pulled off to the left. That's kind of the way I can kind of remember that. You'll need to know those for some homework problems coming up, I think. So there are other types of graphs which we'll talk about very briefly. Frequency polygons, ogives, bar graphs, Pareto charts, time series graphs, and pie graphs, dot plots. We're not going to worry about those. Okay. So frequency polygons, they use the class of midpoints in the middle and frequencies or relative frequencies of the classes. The thing about them is they're really very similar to a histogram in that they display the same information. If I were kind of to draw a histogram, it would look just like that. So to a large extent, they're not very used because they give you the same information you get from histogram. There's also relative frequency graphs where instead of using the frequency along the side, we use the relative frequency along the side, the percentage or the decimal. And yeah, it kind of, when you want to focus more on the percentages, then you use those. So if you kind of look at this one here, here's one, it looks exactly the same. It's using the relative frequencies over here instead of the actual frequencies. So if I look at this one, okay, everyone stare at it, and look at that one. So the only thing that changed was this over here. So look at the frequency over here, 1, 2, 3, 4, 5. Everyone stare at that for a second. That is the only thing that changed. Everybody follow that? So they look exactly the same, just instead of using the numbers, you're using the percentages. It's the only difference. Again, we talked about histograms. This is it with a relative frequency instead of a frequency. You can totally do that as well. No big deal. Ogives use the upper class boundaries and cumulative frequencies, or cumulative relative frequencies, either one. Cumulative or relative, or cumulative relative. The whole idea of ogives, though, that's cumulative. So it's how much is in that class or previous class. So you'll notice that they only go up because they're cumulative frequencies. They never go back down. And then we have things called scatter plots. Scattered diagrams. You guys have seen those before, right? Where every point represents a data point. So this one here would be a data point that has a waist circumference of about, I don't know, like 138. And then maybe they have a, let's see, they have a arm circumference of like maybe like 42 or something like that. So this would be one guy who has a waist circumference of 138 and an arm circumference of 42. So each one of these points represents a person and their data. Bar graphs. So here you have vertical lines that represents the frequencies. So histogram is a type of bar graph, ones where the frequencies go up. But if you're talking about other data, it can go sideways as well. If you're talking about categorical data, like this one. Here's a combined. Here's another one, another frequency graph or bar graph. And then we have Pareto charts. Pareto charts are when you have categorical data. The thing about numerical data is you can't rearrange them. You can't put 2 siblings before 1 sibling, or 0 siblings. You know what I mean? They have to be in order, 0, 1, 2, 3, 4. But if it's categorical, you can rearrange them any way you want. Trolley can come before auto or after auto, doesn't matter. So Pareto chart is with categories, you arrange them from highest to lowest. So you'll need to know that for your project coming up. Time series graphs, you've seen that before. Time is always along the bottom, and then you have something else that kind of moves along as you go. Here's another one where you have 2 different things. You can do it in years as things go along. And then we have pie graphs. So pie graphs are where you have a circle represents 100% of your data, and then the percentage that's in each category corresponds to how much is in there. So married, 50%, half the pie is marriage. How do you figure out how many degrees that is? You take the percentage, multiply by 360 degrees, because there's 360 degrees in a circle. Right? If you do a 360, it's 360. So you multiply those to tell you how many degrees are in each circle. You need to know that also for your project. And the last thing we're going to talk about is this one, which is a dot plot, where it's a graph where the number of things are that have that many. So like this guy, 80, there's 3 people who picked 80. There's nobody who picked 79. 78, there's 1. 77, there's 2. 76, there's 5. Dot plot. So the heights represent the frequencies. Good. All right, have a good couple days. I will see you guys on Thursday.